Greetings, welcome friends, page 133. Here we go. We're going to graph the line x equals 4. We've got to figure out, is that a horizontal or a vertical line? What it's telling me is all of the x coordinates of my points happen to have 4 as their x coordinates. So if I visualize where this would be, 1, 2, 3, 4, 4 comma 0 would be on it, 4 comma 2, right? 4 comma 5, 4 comma 10 would be on it, 4 comma negative 3, all of those would be on it. X equals a number will give you the equation of a vertical line, even though, right, I'd be like, wait a minute, but my x-axis is horizontal. I know that it feels the opposite of what you would expect, and that's actually one of the ways I remember it, like so. Let's see, here we go. That wasn't the best vertical line, but you get the idea. So that's a vertical line that passes through the x-axis at 4. You don't have to pick points in order to graph it. If you're familiar with it, you would have just known vertical line, x-axis, 4. Bam, done. Now, this is not a linear function. It fails the vertical line test infinitely, but it is still a line that I can graph in that form. If I have y equals 2, think about those points as being all points that have y-intercepts of 2. So that would be like 0, 2. If that would be like 2, comma 2. That'd be like 5, comma 2. That'd be like 7, comma 2. Wow, we're getting a lot of squeaking from our desks or something. Negative 3, comma 2. Negative 5, comma 2. Something like that. And so now if I wanted to graph that, I just plot those points, connect the dots. But if you just visualize it as being the horizontal line that has a y-intercept of 2, that is the line you would get. Technically, I should throw the little arrows on the end of this to imply they do go infinitely in those directions, like so. All right, so vertical line is of the form x equal a number. Horizontal line is of the form y equals a number. That's a little bit weird because our x and y axes are not those verticalities or horizontalities. Let's see, here we go. This was an interesting means to graph. Like I said, this I believe is better than making a table of values. This is the intercepts method to graph a linear equation. So if I want to find the x-intercept, we talked about the fact that on the x-axis, all of the y-coordinates have 0 as their value for their y-coordinates for all of the points on the x-axis. So if I want to find the x-intercept, what I could do is plug in 0 for y. So if I have y equals 0 in this function, I would get negative 12x plus 3 times 0 equals 24. That's negative 12x equals 24. Divide both sides by negative 12. And I would get x equals negative 2. So that is my x-intercept. Where I would plot that is at the point negative 2 comma 0, but the x-intercept we refer to as just the x-coordinate. To find the y-intercept, it's similar. Notice all of the points on the y-axis happen to have 0 as their x-coordinate. So here's 0, 0, here's 0, 1, 0, 3, etc. So what you do is you set x equal to 0, and wherever this line exists, if it crosses the y-axis somewhere, it's going to have 0 as its y value, or sorry, x value. So if I plug in 0 for x, I would have negative 12 times 0 plus 3y equals 24. That's just 0, so 3y equals 24. Divide both sides by 3. Right? And I will get y equals 8, right? So that is the y-intercept, the point where my line crosses the y-axis. If I want to think about that as an ordered pair, that's 0, 8. So let's plot these points. So my x-intercept was at negative 2, about there. My y-intercept was at positive 8, about there. And then I can draw my line, and so just connect the dots, and every dot that this crosses, actually, it's also going to cross down here, I believe. Yeah. If I pick my points kind of further away, I can get the line to look better. So every point on this line will represent a solution of the original equation. That equation has infinitely many combinations of x and y that make the equation true. But that doesn't mean everything works, right? Like 1 and 7 won't work. Just like, notice all of the points on this grid, there are lots of points. There are infinitely many points on the coordinate plane, but I'm talking about only the points that land on this line are solutions. So I would, for instance, expect that -4, let's see, let me line that up off the grid, -4 comma -8, I believe would be a solution of this equation if I plugged it in. Let's see, last problem, let's learn from someone else's mistake. Great way to learn. You don't have to repeat your own mistakes. You don't have to repeat the mistakes that others make, right? Wisdom would be to learn from other people's mistakes. And so this is a great opportunity we have right here. So in exercise 25, describe and correct the error in finding the intercepts of the graph. Oh man, this is such a classic. Oh, guys, I love this. I love this. This is amazing. So, all right. So to find, let's see. Let me label their work. So here they were finding the x-intercept. They did that by setting y equal to 0. So notice they plug in 0 for y. Done. 3x equals 24. Done. How did they get to this? What did they do to both sides to get x by itself? Yeah, divide by 3 both sides. That looks all good. X equals 8. Good. All right. To find the y-intercept, what did they do? So the y-intercept, you set the x equal to 0. That wasn't the best song, but I think it's the second best song in the world, to be honest. Just my thoughts. 3x plus 12y equals 24. Plug in 0 for x. This just zeroes out, so I get 12y equals 24. Looks like they divided both sides by 12, and they got 2. Do you guys see what they did wrong? This is what they did wrong. This is the classic mistake. They combined the x-intercept in the y-intercept to be a point that will never exist on our line. Exactly. This is the point 0, comma 2, and this is the point 8, comma 0. All right. Nope. The x-intercept, the x-coordinate is the first one, so x equals 8 would be the first, and then x comma y over here, x comma y over here. Right, so my x-coordinate is 8. X equals 8, right? X equals 8. My y-coordinate was 0, which is what I had up here, and that's why I plugged it in for y, so the y-coordinate is 0. All right? So x comma y, but the classic mistake that they did was they took x equals 8 and y equals 2 and wrongly put it as one ordered pair when those actually represent 2 separate points, not the same point. Wow, I'm so glad we did this problem because this is such a classic mistake. Mathematicians have been making this one for a long time, friends. It won't be the last time we see this one. It's a common one. So put this into your memory. Don't fall into the trap. And thanks for watching, Internet friends. Have a good day.